Okay, hello guys. So today we're going to be reviewing for the end semester 2 tests for this year 2022-2021, and the part 1 is going to be discussing about statistics and probability. Okay, let's just go to number 1. Okay, so number 1, the question is, from each collection of data, calculate the value of the mean, range, median, lower quartile, upper quartile, and the mode. So we have a singular data here. It's a let's say it's a discrete data, and we want to calculate all of these, right? We have like mean, range, median, lower quartile, upper quartile, and mode. Okay, so let's start one by one. Okay, let's start from the mean first. Okay, so the mean is the common word of the word mean is average, right? So average means that you are adding all of the value of the data, and then you divide by the number of data that you have here, right? So it's just as simple as you add all of these numbers, right? Just like 3 plus 4 plus 5 plus 5 and so on and so on, right? 3 plus 4 plus 5 plus 5 plus 6 and so on and so on and so on until you get 10, and then divided by the number of data. So you have to calculate how many data do you have, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we have 12. So it is going to be divided by 12. So if I use a calculator, it will be like 79 over 12. And you can write this down as a fraction like this, or you can write it down as a decimal. Actually, it's up to you. 6.583 recurring 3. Okay, there you go. That is what we call the mean. And then the next one is what we call the range here. The range is quite easy. It's just the maximum value minus the minimum value. So the maximum value here is 10, and the minimum value is 3. It's just like 10 minus 3 is equal to 7, right? As simple as that. Just make sure that the data has been ordered, like from the smallest to the largest, right? Or the other way around. It's up to you, right? So take the maximum value and then subtract that by the minimum value, and you will get the range. Okay, the next one is I'm gonna go to here first. I'm going to go to the mode first. Okay, so the mode is actually the data. The definition of mode is just the data in which it comes up the most, or you can see that the data which has the most frequency. Okay, here if we see like 3, 4, 5, 5, 6, 6, 7, 8, 8, 8, 9, and 10, this 8 here has the highest frequency. Why? Because it comes up 3 times, while the other is less than 3 times. Okay, it comes up only like 1 time or 2 times. The 8 here is 3 times, so which means that the mode is just 8. Alright, it's quite easy. Okay, so now let's go to median, lower quartile, and upper quartile. So in here, guys, so the basic concept of median, lower quartile, and upper quartile is just dividing the set of data into 4 equal parts. Okay, that is the main idea. So I'm gonna rewrite that. It's 3, 4, 5, 5, 6, 6, and then 7 and 8, 8, 8, and then 9, and then 10. Okay, so to divide this into 4 equal parts, the first thing that we normally do is to divide this by 2 first. Okay, 2 equal parts. Be careful in here, guys. When you have an odd number of data and you have an even number of data, it's going to be a little bit different. But the concept is still the same, okay? So when we want to find the median, lower quartile, and upper quartile, the first thing I need to do is to divide the set of data into 2 equal parts. It's going to be on the left side and on the right side, right? Okay, so wait. Okay, so here we have how many data do we have? We have 12 data, right? So which means that the middle of this, if we split this into 2 equal parts on the left side and right side, this what do you call it? The cut is going to be like in here, right? Sorry, I'm going to use another color. I'm going to use green. Okay, there we go. Like in here, right? Right? Why? Because if we split it in here, you'll have 1, 2, 3, 4, 5, 6 data on the left side, and then we have 1, 2, 3, 4, 5, 6 on the right side, right? We have 6 data on the right side and then 6 data on the left side, right? So remember that this cut over here must be exactly in the middle. okay, exactly in the middle. So in this case, right, we have an even number of data, so which means that the median is going to be like we don't see any number that exactly on the data exactly the median is, because it's like, oh, it's there but you don't see any number, right? The cut is there but we don't see any number in here, right? We don't see that. So which means that the median, or what we call the middle quartile, or the quartile 2, is the same thing like median. It's just like the number between the 6 and 7. Okay, so the 6 and 7, if you want to find out the number between that, it's just adding those two numbers and then divided by 2, like 6 plus 7, because this is 6 and 7, also on the left side and the right side, and then divided by 2, and you will get 6.5. So this is the value of the median. Okay, so after you get this median, or the quartile 2, or the middle quartile, you can find the lower quartile and the upper quartile by using the left side of the data, after we cut this into half, right, 50-50, and then on the right side of the data, the left side of the data, we can use it to find the lower quartile. Okay, so these data here, we can find it like the lower quartile, and this is going to be the upper quartile. Okay, so let's start from the lower quartile first. Okay, so we're going to start from the left side. So because we know that this 6 is still here, it's still on the left side of the data, so it should be included here. So this 6 data here, actually you do the same thing like you do with the median. And while finding the median, it's just like dividing the whole data into 2 equal parts, right? And for the lower quartile, you split the data on the left side after you cut this, right, by 2 equal parts. It's the same thing, right? So if I cut that, the cut will be exactly in here, right? Because if I split this, I have 3 data over here, right? And then I have 3 data over here, right? So which means that this cut over here, this cut here, is going to be exactly in the middle of that 6 data on the left, right? So I'm going to write down here. So here we go. So in here is going to be the quartile 3. But again, we don't see any number here, right? So you do the same thing like this one, right? We just add these two numbers and divide by 2. And so the same thing with this one. So you add these two numbers and divide it by 2, right? So it's just 5 plus 5 divided by 2 happens to be just 5. So that is, sorry, this is quartile 1, guys. Sorry, quartile 1, or lower quartile, yeah, lower. Okay, so you do the same thing on the right side, right? You do the same exact thing, but this time you cut into 2 the part on the right side of the median, or the middle, or the median. Yeah. Okay, I'm gonna use other color here. And if you see here, we have 6 data, right? And if you cut this by 2, which means that you're gonna cut it here, right? Exactly there, because in here we have 3 data, and then also we have 3 data. Okay, just to make sure that it is actually exactly in the middle, right? So which means that this is going to be the quartile 3, or the upper quartile, right? Is this, because here we don't have any number, right? But it's just like between these two numbers, you do the same thing like before. It's like this 8 and then this 8 and then divided by 2. So 8 plus 8 divided by 2, it happens to be also 8. Okay, so that we have the mean, and then we have the median, we have lower quartile, upper quartile, the mode, and the range. Okay, so basically you're doing the same exact thing like this, like number 1A and 2B. Okay, I'm going to explain B, but I would like you to answer the C by yourself. Okay, so let's do the same thing. Okay, guys. So I have set of data here, and all of these data has been ordered 1, 2, 2, 4, 6, 10, 10, 11, 13, 14, 16, 19, and 20. So let's start from the easiest part first, right? The easiest part is the mode, right? It's quite easy. The mode is the data in which it comes up the most. And here we have this 2 times, and this one is also 2 times, right? This 2 comes up 2 times, and 10 also comes up 2 times. Okay, be very careful, guys. In here, you don't divide these two numbers, okay? Because we have the same frequency for 2 and 10, so the mode is 2 and 10. It's not 2 plus 10 divided by 2, yeah? So be very careful with that. That is the mode. And then let's go to the median first. Okay, median, the range. The easiest part first, it's okay. The range, okay? Because the the data has been ordered from the smallest to the largest. So we can say that the maximum value is 20 and the lowest value is 1. So which means that the range is this 20 minus 1 is equals to 19. Okay, so the mode and range has the easiest part to calculate. Okay, so that's the mode and range. And the next one, we can calculate the mean. Okay, so I'm gonna write down mean here. Okay, so I'm not going to calculate this for you guys, so because I'm just going to show you how calculate by yourself. Okay, it's just like, remember that mean is the same thing like average. When you see most people say it's average, right? So it's just adding all of the values in here, adding all of them, and then divide that by the number of data that you have, right? So it's just 1 plus 2 plus 2 plus 4 plus 6, and so on and so on and so on until you get to the final data, which is 20, right? So all of these data. And then you divide it by the number of data. Number of data is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's equal divided by 13. Okay, so just calculate yourself using the calculator and you will get the number. Okay. Okay, the next one is the the median, lower quartile, and upper quartile. Like I said before, like I have previously explained to you before, guys, that the concept of quartiles and median is actually just like dividing quartiles is just dividing the set of data into 4 equal parts. Okay, to divide that, you need to divide the whole data into 2 equal parts, the left side and the right side. Okay, so in here, if I say, because I have 13 data, right, which means that the middle data is exactly going to be, is the right? Okay, 1, 2, 3, 4, 5, 6, 7. Okay, it's actually, is it here? I think it's here. Okay, so if I pick that number there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. So, okay, let's just assume that we pick that number over there. Okay, so to make sure whether this is going to be the mean or not, you need to see how many data on the left side and on the right side of this data, right? So I have 1, 2, 3, 4, 5, 6, 7. 7 on the left side. We have 1, 2, 3, 4, 5. 5. Oh, which means that 11, it's not going to be the median, right? Because it doesn't divide this data set into 2 equal parts. Okay, so I'm going to erase that. Okay, and here I'm going to pick this one now. Okay, exactly there. So I can see that on the left side I have 1, 2, 3, 4, 5, 6 data, and on the right side I have 1, 2, 3, 4, 5, 6. Oh, I have 6 data. So which means that 10, this guy over here, is the number in which it divides this set of data into 2 equal parts, right? 2 equal parts. So which means that this is going to be the median. Okay, so that's the first one. The second one, okay, the lower quartile and the upper quartile. Okay, remember that when you do the same thing, right? But for the lower quartile, you do the same thing like when you do the median, but in the median you cut in half the total of the data, right? The whole data. Meanwhile, on the lower quartile, it's just like on the left side of the data after you cut it, right? So you're going to involve all of these numbers. Remember that this doesn't include because it has been taken by the median. The previous question here, there's no number here, right? So there's no data in here. It's taken so that it will be the median. The same thing like this one. No taken, because there's no number actually here, right? But for this case, for the second case in here, guys, this 10 has been taken. This guy over here has been taken. The value has been taken into the median value, right? So you don't include that on the left side, on the right side, or on the right side. You don't include it, right? Okay, so if I'm gonna erase that. Oops, sorry. So which means that which means that if I involve the left side of the data here, right? I have 1, 2, 3, 4, 5, 6. And if I cut this into 2 equal parts, it's going to be, the cut will be equal, they said here, right? Because in here we have 3 data on the left and 3 data on the right. Okay? So that is going to be the cut for us to find the lower quartile or the quartile 1. And as I've previously mentioned, if you don't see any number in here where you cut it, you just add in these two numbers, right? 2 and 4, this one and this one, right? And then you divide it by 2, right? So it's 2 plus 4 divided by 2 is just equals to 3. Okay. And the last one is the upper quartile, which is this one here. It's going to be involving the data after we cut it, the data that we cut, but this time on the right side, right? So it's going to be this guy here, right? So these guys here, right? And you divide those data 11, 13, 14, 16, 19, 20 into 2 equal parts. So if I cut it, it should be in here, right? Because I have 3 data here and I have 3 data here, right? So the quartile 3 or the upper quartile is just like adding these two numbers and then you divide it by 2. 14 plus 16 divided by 2 is equal to 15. Okay, so there you go. You have number 1. Okay, guys. So for number 2, we have a table, the frequency distributed table like this, and it is as the mean, mid, range, median, quartile, and upper quartile. It's the same thing, the same question as number 1, but number 1 we see a singular data, and it is like what do you call it? It's represented by a single data. And here the data is actually, yes, it's singular, but we represent this in a form of table. Okay, so I would like to understand a couple of things first. The first one is, what does this mean, right? Okay, let's read the question. The following table shows the number of marbles that students have in a school, and it said that outcome 10 and then frequency. So what does this mean? It means that there are 4 students. Okay, I'm gonna repeat. This means that there are 4 students who have 10 marbles. Okay, so the next one here, what does this mean? It means that there are 2 students who have 20 marbles, and so on and so on and so on, so on, right? So that is what the first thing that you need to understand. So how to read this this, what you call, the table. Okay, and then let's go to the question that is quite easy to be answered. Okay, the mode and the range, right? It's quite easy. Right, so the mode here, guys, so I'm going to go to question B first. The mode, right? The mode is the data in which it has the most frequency, or it shows up most, right? So in here, guys, you only need to see the frequency. As you can see that the highest frequency is 8, right? So which means that there are 8 students who have 40 marbles. So which means that the mode is going to be 40. Okay, be very careful. The 8 is not the mode. The mode is 40 because the 8 represent how many times does that 40 comes up in the data. Okay. Okay, the next one is the range. Here we go. The range is also easy because we know that the highest value is 50 and the lowest value, sorry, the lowest outcomes and the highest outcomes in here. So be very careful, guys. You need to focus here, right? And in terms of the value of the data, right? So which means that the range is going to be 50 minus 10. So 50 is the maximum value of the outcomes and 10 is the minimum value of the outcomes. Okay, so be careful not to get here. Okay, that is not for the range. Okay, so the range is just like, oh, the maximum value is 50 and the minimum value is 10. So it's 50 minus 10 is equals to 40. Okay, the next one, I'm going to go to the mean. Okay, so the mean here, guys, if you see the data in a table, if you want to find a mean, the first thing that you need to do is to calculate how many data that we have, right? Because in calculating the mean, you need the total or the sum of all of the data, and then you divide it by the frequency, right? Or the data that you have. In here, guys, as you know that this 4, 2, 5, 8, and 1, all of them actually represent the number of data that we have, right? So if you total that, I'm going to write that in sigma f, right? Sigma means the total of the sum, or the sum. It is going to be equal to 4 plus 2 plus 5 plus 8 plus 1. 4 plus 2 is 6, 6 plus 5 is 11, this is 19, it's going to be 20. So it's going to be equals to 20. Just add them, you can use a calculator. This equals to 20. So sigma f is going to be equal to 20. Okay, so we're not done yet because we need to find the total value of the data. Okay, one thing that I also want you to understand. So if we write this down as a single data, like we did for number 1, this will look like this, okay? 10, 10, 10, 10, right? So we have 4 of 10, and we have 20 to 20, and then 20, right? 20, 20, and then 30, 30, 30, 30, 30, right? We have 5 of these, right? 5 of these, and so on, so on, so on, so on, right? So this is, if you represent this like number 1, it will be like this, but it's going to be long because we have a lot of data. We have 20 data, so I'm going to erase that. So instead of doing that, we're going to add one more column here, is what we call the fx. So what this fx means is just like multiplying the outcomes with the frequency. Okay, so I'm going to write down fx in here, and basically you're just like multiplying, right? It's the same thing like if I have 10 of 4, how many what is the total, right? It's just like 10 times 4, 10, 10, 10, 10. 10 plus 10 plus 10 plus 10 is 40, right? I can get this 40 by just multiplying this and this, right? It's the simplest thing. Okay, so yeah, just do that, and we'll see that 20 times 2 is also 40. Oh, sorry. It's 40. And then the next one is 30 times 5 is 150. And then 40 times 8 is 320. And the last one, 50 times 1, is equals to 50. Okay. So this is the sum of 10, this is the sum of 20, and so on, so on, so on. So which means that the total of the value of the data from the data is just 40 plus 40 plus 150 plus 330, 320, and then plus 50. Okay, let's add them. This plus this is 200, this plus this is 420, and then plus 80, right? It's going to be 600. Okay, so the mean itself is just, if we are using a distribution table, so which means that the mean is just the sigma fx divided by the sigma f, which is going to be 600 divided by 20. It's going to be, I'm going to cancel this 0, and this is equals to 30. So that is the value of the mean. Okay, the next one, the median, lower quartile, and upper quartile, is basically the same thing, guys. Remember when we do it for number 1, right? We just like split into 2 parts and then split it again on the left side and the right side, right? For this one, we can't really see which one is in the middle, right? We can say, oh, this is in the middle, but it doesn't mean that this is in the middle because it's like 10, 20, 30, 40, 50. It means that the 30 is exactly in the middle. No, you have to understand that this is exactly in the middle of data. Okay, so how to find the median, lower quartile, and the upper quartile? This we can find by using another help from the table, right? We're going to use another column here, is what we call the CF, which is the cumulative frequency, okay? CF, or cumulative frequency. Okay, so this is how you fill this, okay? So the first number should always be the same with this one, okay? Remember that you're focusing on the frequency, okay? Not the x, it's just a frequency. As this is 4. And then you add it with the next number below the 4, which is 2, right? 4 plus 2 is equals to 6. And then you add it again with the number after that, which is 11. And then add it again, which is equals to 19. And then add it again is equals to 20. Okay, so I'm going to repeat. I'm going to repeat the, what do you call it? How to read this. What does those number 4, 6, 11, 19, and 20 means, okay? So in here, 4 in here, it means that data number 1 until data number 4, right, is 10. This guy is data number 1 until number 4. Okay, so this guy over here, the 6, is data number 5. How can we start from number 5? Because we already have data number 1 until number 4 in here, right? Until 4, after 4 is 5. So data number 5 until number 6 is this guy, 20. Alright? Okay, the next one, this 11. Oh, which means that the data number 7, right? Why? Because we ended up in the 6th data, well, previously, right? So which means that we're going to start from data number 7 until number 11 is this guy over here, which is 30. And so on, so on, so on, right? So that is how you read the CF, or the cumulative frequency, right? Okay, now, how can we use this to determine the median, the lower quartile, and the upper quartile? Okay, as you can see that we have a total of 20 data, right? So I have like 20 data, now data number 1, number 2, and so on, so on, so on, until I get data number 1920. Okay, where do you think we should cut it so that it will divide these two data into equal parts, right? The answer is in the middle between data number 10 and data number 11, right? As you can see that, oh, on the left side I have 10 data, and on the right side I also have 10 data. So which means that the median is going to be between data number 10 and data number 11. Okay, data number 10 and data number 11, between those two numbers. Okay, so what we're going to do here to find where is data number 10, what is data number 10 and what is data number 11, is that we are going to use that CF, or the cumulative frequency, right, to determine what is the data number 10 and what is the data number 11. Okay, so let's go back here. So I can say that data number 10 is in here, and data number 11 is a coincidence. It's a coincidence that it also is here, because you can see that here data number 7 until 11. So data number 7, number 8, number 9, number 10, number 11 are all this guy, 30, right? So which means that if I want to find the median, which means that I have to add data number 10 and data number 11 and then divide it by 2, right? Data number 10 is 30 and data number 11 is also 30, coincidentally, and then divide it by 2 and then you will get 30. Okay, so that's the first thing. Okay, and then after you get the median, you do the same thing like number 1, guys. So you split the data on the left side, right? This 10 data on the left side, these guys, like 10 data, and you split it into 2, right? So you see that, oh, the middle data of this 10 data is data number 5 and data number 6, right? Data number 5 and 3, 4, 5, 6, 7. Oh, I'm sorry. I'm gonna rewrite that one. Sorry. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. There we go. So this same data here, you split it into 2 equal parts. It will be here, right? Because you know, oh, we have 5 data over here and we have 5 data over here. So which means that this is going to be the quartile 1, or the lower quartile. Remember, it's not this, it's not, the value is not 5 and 6, but it's data number 5 and data number 6. Let's go back to the table again. Where's data number 5, or what is the value of data number 5 and what is the value of data number 6? Data number 5 and data number 6 coincident is a coincidence that they have the same value here, right? Data number 5 and data number 6, right? Data number 5 is 20 and data number 6 is also 20. So which means that the quartile 1, or the lower quartile, is just 20 plus 20 divided by 2 is also equal to 20, right? So that is for the quartile 1. And the same thing goes to the upper quartile, right? So you can see data number 11 until 20, right? On the right side, I'm going to rewrite this, right? Data number 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Okay, let's divide those into 2 equal parts. It's actually going to be here, right? Because we have 5 data over here and we have 5 data over here, right? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So which means that the quartile 3, the upper quartile, is going to be in the middle of data number 15 and data number 16. Okay, let's continue to the table. So this guy means that this is going to be data number 12 until number 19, right? Because we ended with 11, so we start with 12. And then in here we have 19, so it's going to be data number 12 until number 19. Is 40 is this guy, because this guy is here, right? So because we know that in here data number 12 until 19 is 40, we can say that data number 15 is 40 and data number 16 is also 40, right? Because data number 12, 13, 14, 15, 16, 17, and 18, and 19 is 40, all of them, right? So I can write down that as, I can find the value of the quartile, the upper quartile, which is adding those two numbers, right? So 40 plus 40, because data number 15 is 40, data number 16 is also 40, and then divided by 2, that equals to 40, right? So this is the value of the third quartile. For number 3, it's quite easy, guys. I'm pretty sure that you understand and can what do you call it, interpret the meaning of this pie chart, right? Okay, so here we go, guys. The question here below is a chart of how workers go to work. If there are 200 respondents, how many of them who A, go by bus, and B, go by car? It's quite easy, guys. Just if it is like we already know the numbers, right? We have the 30% of the worker go by bus, 50% of the worker goes by car, and 55% or the rest of them are walking. Okay, so in here, which means that how many workers go to work, because we know that how many go by bus, because we know that the bus represented by the 30% is just like, it's just like 30% multiplied by the total number of respondents, right? So times it with 200. Just use a calculator, guys. It's just like 60 workers. It's quite easy, right? And the same thing like this one, guys. We have car represented by 15% in here, so it's just like 15% times 200 is going to be equals to 30 workers. For number 4, you can actually do this by the help of a table, or you can just write this down as a singular data. Okay, so again, it's up to you. Which one do you think is the best method for you to understand? Okay, so for this number 4 here, I'm gonna explain it using the method like you do in number for number 1. Okay, so let's read the question first. Okay, the following diagram is the result of a test from grade 8 students. So it comes from 3, 4, 5, 6, 7, 8, 9, and 10. Okay, and then calculate the mean, mid, range, median, lower quartile, average quartile. So actually, it's the same thing, right? By using the single data, because the data is not that much, right? So we can use that, or you can use the table. It's up to you. But here again, I'm going to write this down as a single data like this. Okay, so what does this bar means? Okay, it means that the outcomes of 3 comes up 3 times. So I'm gonna write down 3, 3, 3. Okay, the next one, 4. And in here we have 3. So 4 comes up also 3 times. So 4, 4, 4. Okay, and the next one, 5. And then we have this one, which is 6. So 5 comes up 6 times. 5, 5, 5, 5, 5, 5. Okay, let's do the rest one. So 6 comes up 5 times. So it's 6, 6, 6, 6, 6. And then we have 7 comes up 4 times. 7, 7, 7, 7. And then 8 comes up 2 times. 8 and 8. And then 9 comes up 4 times. 1, 2, 3, 4. And the last one is 10 comes up 3 times. So it's 1, 2, 3. Okay, it's a little bit long, guys, but it's okay. Okay, so the first thing that we're going to calculate is the easiest one, guys. Okay, so the mode and range is quite easy. The mode is just the data in which it comes up the most. Okay, you don't really need to see it from this list, guys. You can see it from the graph. Okay, from the graph in here, we can see that the highest frequency is the tallest, right? The tallest bar. The tallest bar is this guy over here, right? Because that 5 comes up 6 times. So the 5 comes up the most, which means that the mode is just 5, because 5 comes up the most, the tallest one. Okay, and then the next one is the range. The range is also the same, guys. It's just that the maximum outcomes minus the minimum outcome. The outcomes is this one, guys. Okay, the outcome is 3, 4, 5, 6, 7, 8, 9, 10. So the maximum value of the outcome is 10, and the minimum value of the outcome is 3. So it's 10 minus 3 is going to be equals to 7. Okay, that's quite easy, right? And then we can start by calculating the mean. Okay, so there's a lot of method on how to calculate this, but yeah, I'm going to show you just one or two method on how to do this. You can use other method. It's up to you. Again, it depends on how you understand. You can get more grasp into the concept. It's up to you. Okay, so I'm going to do it like this, guys. So because we know that we need to add all of these numbers, right? and then divide this by the total number of the data. So the first thing I usually do is to calculate how many data do I have in here. Okay, so how many data do I have in here is just calculating the frequency, right? The frequency is denoted by the vertical axis, which is this one here. So this one has 3, this one has 3, this one has 6, this one is 5, this guy has 4, this is 2, and this is 4, and then this is 3. Okay, so the total frequency is just adding all of those numbers, right? 3 plus 3 is 6, 6 plus 6 is 12, okay, 12 plus 5 is 17, 17 plus is 21, yeah, 21, 21 plus 2 is 23, 23 plus 7 is 30, okay. So if you add all of the numbers like that, it's going to be equal to 30, which means that we have 30 data, okay. And the next one is to add all of the numbers, okay. So you can use a table like the question number 2, right? Or you can just like, oh, I'm just going to do it like this. I'm going to multiply this number with this number with this number, and then this number with this number, and this number and this number, and so on, so on, so on. After that, I get all of the result, and then I will add them up. Okay, so that is one of the way in how to do it. Okay, so for this guy, it's going to be 12, right? Because sorry, 12, 9, yes, right? 3 times 3 is 9, and then this guy is 4 times 3 is 12, and then that guy 5 times 6 is 30, and then 6 times 5 is 30 also. 7 times 4 is 28, and then 8 times 2 is 16, and then 9 times 4 is 36, and the last one, 10 times 3 is equals to 30. Okay, so this is going to be the sigma of x, right? So just multiplying the x, or the value of the outcomes, with the frequency, okay? So if we add them, let me use my calculator. It's going to be 21 plus 60 plus 28, oops, sorry. I'm going to turn on 21 plus 60 plus 28 plus 16 plus 36 plus 30. Okay, it's going to be 191. So which means that the mean is going to be equal to 191 divided by 30. Simple as that. So this guy divided by this guy. Okay. And if we change that into a decimal number, it will be 6.36666. Okay, so we have already get the mean, the mode, and the range. Now, to find the median, lower quartile, upper quartile, you do the same thing like number 1. Remember, guys? Okay, as long as you know that, oh, this has 30 data, right? What is the middle of 30, right? The simplest method, and where is the data in which it represents the median, which is, we know that we have 30 data. It means that the half of this is 15, right? So which means that you need to have 15 data on the left side and 15 data on the right side, right? Which is one, right? So I will get like, we have 3, 3, 6 is 9, 9 plus 5 is 14. So which means that it's going to be, maybe it's about here, I think. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, sorry, it should be here. Yeah. Right? Should be there, right? Because we have 15 data on the left side and we have 15 data on the right side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? 15 data. And let's check to the right side. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so that match, right? So which means that the middle data, or the median, is right there on the cut on the middle that I have just made, right? So which means that the quartile, or the median, is going to be there between these two numbers, which is 6 and 6. Because we don't have any number in the middle of that. It's just like adding these two numbers, right? And then divided by 2. You get the median, right? Okay, the next question is the lower quartile. Remember that the lower quartile means that we're going to do the same thing like this, but we do it only on the left side after we cut it by the median, right? So we're going to cut exactly in the middle for these data. Okay, so we have 15 data. So what do you think the middle of the 15 data is? Data number 8, right? The easiest way to do this is just like 15 plus 1 is 16, right? Divided by 2 is equal to 8. So the data number 8 is going to be in the middle. So let's just do that. 1, 2, 3, 4, 5, 6, 7, 8. So here we go. Exactly there, okay? So this is going to be the cut here. It's going to be quartile 1. Okay, let's check, okay? So because we have taken this value as the quartile 1, we need to check is there the same number of data on the left side and on the right side of this cut here, right? So we have 1, 2, 3, 4, 5, 6, 7. We have 7 data on the left side. We have 1, 2, 3, 4, 5, 6, 7. Oh, we have 7 data on the right side, and we have 7 data on the left side. So which means that that is going to be the quartile 1, which is going to be equals to 5, because that is going to be just exactly that number. Okay, we do the same thing on the right side, right? Remember, just cut that into half, right? So the same thing, right, guys? You have 1, 2, 3, 4, 5, 6, 7, 8 on the 8th data from where you started. So I'm going to start from this, right? This guy over here, right? 1, 2, 3, 4, 5, 6, 7, 8. So it's this guy over here. If the quartile 3 is equal to 8, let's prove that. We have 1, 2, 3, 4, 5, 6, 7 data on the left side. We have 1, 2, 3, 4, 5, 6, 7 data on the right side, right? So it's proven that if we take that 8, this guy, this 8 over here, it's going to divide these two data into 2 equal parts. So which means that the quartile 3 is going to be equals to 8. For number 5, actually guys, this is very similar with number 2, but the difference is that for number 2, the table only consists of like a singular data, like the outcomes are only like 10, 20, 30. But this guy here, the table here, it is what we call a group frequency distribution table, right? Like this one, guys. Like this is not just 40 and 50, right? It's actually is 40 and from 40 until 50. So it's like 40 but less than 50, right? Like 40, like 40.5, so on, so on, so on, and 41, so on, so on, until it's like less than 50, okay? So you do the same thing after me. Okay, so the first question, let's say I have a group frequency table like this. We have speed and frequency, okay? And then the first question, are these data included into discrete or continuous data? Okay, remember guys, what is the difference between discrete and continuous? Discrete is represented by a whole number, right? Like if you have a pen, how many pens do you have? Like I have 3 pens. You cannot say like I have 3.5 pens. Or if you have a pet, let's say you have a cat. Okay, how many cats do you have? I have 5 cats. I have 6 pets. You cannot say I have 2 1/3 cat. Although it's still a baby, you cannot say it's 1/3 of a cat, right? Maybe it's because it's small, but you just say it's 1 cat, despite the size of the cat, right? So that is what we call a discrete data. Okay, discrete means that it is going to be represented by a whole number. And then the next one is continuous. So what does continuous mean? Continuous means that the data can take any value in the number line. Remember in number line, right? We have like -1, 0, 1, 2, 3, and so on and so on, right? And for continuous data from discrete, you can only take like this number here or this number here. But for continuous data, you can take any place in this number value. So for example, I can take it here, like exactly in the middle of 1 and 2, like 1.5, right? Or maybe a little bit like here, like 2.1 or 2.11123.4. I don't know, like any numbers in here, right? So you have like a decimal place, right? And as you can see here, guys, if you see the table, the speed is like from 40 until 50, like less than 50, right? So which means that if you can see speed can be represented as a fraction, can be also represented by decimals, right? Like what's your speed? Like 40.5 kilometers per hour, and so on and so on, right? You can have like this decimal numbers, right? So example, like your height also a discrete, it's a continuous data, right? Your height can be like, oh, okay, my height is 165 centimeters. It doesn't mean that it's exactly 165. Maybe like add like 1 millimeter, like 165.1 millimeter, right? So that is what we call continuous data. So which means that in here, speed, Okay, speed. And here speed is included into a continuous data. Okay, not a discrete data, because we can represent speed as a decimal number, right? Like 40.5 kilometer per hour or meter per second or anything. Okay, so that's the first one. The second one, the B, C, and D is basically the same question, like number 1, 2, 3, 4. All of them are the same. We do the same thing. Okay, I'm not going to explain all of them because the calculation. You can just do it yourself. I'm just going to explain the method and how to do this. Okay, so I'm not going to explain the median, lower quartile, upper quartile, because you have already I've already explained that for number 2. And for this one, guys, the answer for the median, lower quartile, upper quartile, and modal is just the class. Okay, not the exact value, like the estimation value. Sorry, right? So I'm going to go straight to D. Okay, the modal class. Right? So remember that when you see the mode or the modal class, in here you can just see the class in which it has the highest frequency, right? So as you can see, this line over here has the highest, this guy over here, yeah, this line here, has the highest value of the frequency. So which means that the modal class is just 80 till 90. That's it. Because this guy, this 2, is has the highest frequency. So the modal class, I'm not talking about the estimation of the mode, right? Because you're going to study that in grade 11 later. You are still in grade 8, so please do not use that method, because it's not asking about the modal estimates, the estimation modal value, but it's the modal class. Okay, there's this word here that is representing what it is asked. Okay, so again, the modal class is class 80 till 90. Okay, so that is pretty easy, right? So the same thing with the median, lower quartile, upper quartile classes. You do the same thing with like the method like number 2. You can go back to number 2 if you forgot, and then you do the same thing, right? You do the same thing. Okay, so in here I'm gonna add all of them. I'm going to calculate how many data do we have, right? 1 plus 3 is 4, and plus 7 is 21, and this is 60. This is 108. And 108 plus 21 is 129, right? Okay, I have 129 data. Okay, I'm gonna erase that. Let me check it again, guys. 1 plus 3 plus 17 plus 39 plus 48 plus 17 plus 4. Yeah, 129. Yeah. So the sigma f, sorry guys, I'm going to put it here a little bit down because I don't have any space there. Sigma f is going to be equals to 129. It means that I have 129 data. Okay, we're going to use that to calculate the mean and also to find out where is the median, the lower quartile, upper quartile classes. Yeah. Okay. So in order to find the median class, okay, remember that the median is the middle data, right? We have 129 data. So what number of data is in the middle? So it's actually quite easy because we have an odd number of data, which is 129. So the data for the medians, not the value of the median, okay? The data of the median is 129 plus 1 divided by 2. 129 plus 1 is 130. Divided by 2, it will be 65. So which means that the median is in the 65th data. Okay, 65th data. So if I use the CF in here, I'm going to use the CF, remember? It's like 1 and added with 3, 4, added with 17 is 21, added with that is 60, added with that 108, added with that 125, and 129. So where is the 65th data? It's in here. Okay, why? Because in here is data number 61. Where do I get the 61? Because in here we have 60. After the 60 is 61. So which means that data is data number 61 until data number 108, right? Data number 61 after this is 61 until 108 is that guy is 80 until the class is 80 until 90. right? So which means that the median is this one, this guy, right? This is going to be the median class, sorry. Okay, do the same thing. When you have 129 divided by 2, 65 data, right? So the 65th data is going to be exactly the median. So which means that we have 64 data on the left side of after we divide that, right? Remember, like data number 1, number 2, and then you have data number 65, and then you have until data 129. It means that this is going to be the median, which means that we have 64 data in here, right? And then we also have 64 data in here. Okay, so where can I get this quartile, the lower quartile? The 64, you divide it by 2, you have 32, right? You have 32, but remember that if this is an even number of data, we have even number of data. So the median of the middle of this data, which is the quartile 1, is not going to be data number 32, but it's going to be data number 32 and number 33, and then you divide it by 2. So if it is an even number of data, right? If it is odd data, just take the numbers, right? 121 plus 1, you can use this method here, right? If it is an odd number of data. But if it's even number of data, because you know that 64 is even, right? 64 is even. So divided by 2 is 32, but the median, the middle, sorry, in this term, I'm going to go to the left side of the data, which is this one, is going to be like the 32nd data and the 33rd data. And then divide by 2. I can see that the 32nd and 33rd data is actually in here. Because I know that this is data number 22nd, right? Because after 21 is 22nd, right? Until data number 60, which means that data number 32 and data number 33 is also here. So which means that the quartile 1 class is going to be 70 until 80. And you do the same thing with this one, okay? I'm not going to explain. So the mean is actually the same thing, guys. But remember that this is a little bit different, guys, because we don't really know which one to multiply. Okay, I'm going to go to the question in here. I'm going to copy this one first. I'm going to put it here. Oopsie. Okay. Okay, I'm going to erase all of them. Okay, so when we want to find out the, what do you call, the mean, guys, we don't need the CF. What we need, sorry, it should be the 129. So it should be putting that. Okay, wait. Okay, so to find the what do you call it, the mean, guys, if it is a group frequency distribution table, you need to, like, you know that you have to, like, use the fx, right? What you did for number 2, like we have this fx. But the question is, what number should we multiply by 1? Is it the 40 or is it the 50 or other numbers, right? We don't really know how to do that. But in here, guys, that's why we need what we call the midpoint for each of the class. Okay, so for this number 5, I have given you an information that the midpoint are 45, 55, 65. This one here, this guys. So 45, 55, 65, it's going to be like in here, guys. Like in here, the midpoint is 45, 55. I'm going to make it like a line here. So it's, okay. Okay, 55, 65, 75, 85, and then 95, and then 105, right? So the fx that you are calculating, like number 2, this is this one here. The x is this one. So when you want to find the fx in here, right, it's just multiplying, like 1 times 45 is just 45, right? 3 times 55 is 165, and so on, so on, so on, so on. And after you get this, you will get sigma fx, right? Right? You just add all of the numbers here, right? After you multiply. Okay, so where do you think you get this 45? It's just like in the middle of 40 and 50, right? Like you add those two numbers and then you divide by 2, right? 40 plus 50 is 90. 90 divided by 2 is 45, right? This is 45. It's the same thing. 50 plus 60, 110. Divided by 2, you get 55. All right? So, yeah, and here I have given you the midpoint. And then you can just do the same exact thing to find the mean like number 2. Okay, so I'm not going to explain all of them. You can do it yourself.